All right, so an API, for those of you who are unaware, is effectively an interface into a system. Now, to the developers amongst us, when we hear API, typically we think of those interfaces which are typically exposed over protocols such as HTTP or HTTPS, for example. However, there are also other kinds of APIs. There are those which, say, for example, accept messages from a queue, or even those that accept files containing a specific format. Okay. However, lately the more modern APIs tend to be exposed over HTTP. Now, in general, when we are working with APIs, typically we would like them to be intuitive to use, but also rich in content. And what I mean by that is, if you're a developer, the quicker you are able to use an API, the faster you can kind of get along with the target of your project effectively. And in fact, those APIs which are intuitive to use typically gain faster adoption and tend to be kind of heralded as, I wouldn't say leaders, but they tend to get a good reputation in the market. However, if you're building an API and you're trying to aim for these 2 points, it's not entirely an easy feat. In fact, one of the biggest challenges we find with APIs is to actually understand the business processes behind the API and the technical limitations of the underlying system. This especially applies to those systems, say, for example, Ingram mentioned that there are mergers between companies and you want to amalgamate your old systems versus your new systems. So you need to understand what the recently acquired systems tend to support. So it's very important that when you are building APIs, you collaborate with the right stakeholders to get these limitations and these business processes well documented before you actually start. Now, to the developers amongst us, even though the recent rage with APIs, it's relatively recent. HTTP APIs have been around for a while. Okay, they aren't really anything new. However, they've tended to become more mainstream because if you look at the history of APIs, you can see that the standards have evolved by quite a lot, and along with the standard, the toolings for those standards has evolved as well. Now, business has bought into the idea of an API because, looking at the past, it was relatively difficult to integrate systems because of this short-sighted approach. But now, given that APIs are relatively easy to define, their cost is typically not as large. Other than that, we've also seen that some products that come with APIs are chosen above others which do not. And in fact, this becomes a defining factor when purely by virtue of having a system that's not getting in the way, kind of it allows you to move faster. Now, on top of that, when you want to expose your systems over your APIs, earlier, or rather, in the years past, this was done using either bespoke standards or standards that were relatively difficult to consume. Nowadays, given that APIs are relatively easier to develop, they are also considered as viable revenue streams as well. And as a result of having these APIs, you can expose different areas of your system and even tier different parts of your internal systems behind different SLAs, for example, or different groups of customers, especially. So, if if we look at where APIs came from, initially APIs were stateful. So the idea was that you would open a session against the system, you would perform a number of actions, and then you would close your session at the end. However, for developers, this tended to cause a lot of problems because the underlying logic of the system typically permeated through the interface. You weren't getting much by defining a custom API because of the way the system was built initially. Other than that, defining these business processes across stateful APIs, it tended to make thinking about the unhappy parts for developers relatively more difficult, and certain hard questions were asked that I find that the answer to all of these questions was basically it depends, which is like one of the it's not a nice position to be in. In fact, some of the questions that that tend to come up with when it comes to stateful APIs is, when there's an error, how do we roll back? Effectively, how do we clean up the system based on the requests that came earlier? And how do we recover? Now, the solution to this is to build stateless APIs, and nowadays modern APIs tend to be stateless APIs. Now, the difference between these kinds of APIs and stateful APIs is that typically state is stored on the client, and then your requests are effectively self-contained. So the API implementation, or rather the business logic behind the stateless API, will validate the request, the business logic, and so on. Typically, from what I've seen, you tend to get an all or nothing approach. So it's safer than having a stateful API, because you know that if a request has failed, then your state on the end server hasn't been effectively touched. Now, these APIs, compared to stateful APIs, they are much easier to use, and their documentation is typically self-serving for developers to get started. And this is also by virtue of the tooling that has been built over time. In fact, if you have to build an API, there are now pretty tight standards, so it kind of makes your life easier because you have a framework by which you need to abide by. So at the start, we started off with RPC standards, which is effectively having a standard bespoke for each type of integration, but then later on we found the introduction of SOAP, where the WSDL file kind of defined what each request and each response would look like. So there was a hard contract by which the consumers and the implementation of the API had to abide by. Now, SOAP was considered to be not the best solution, purely by virtue of the technology that it was using, being XML. XML is relatively heavyweight. Over time, the standard of SOAP became even tighter, and this kind of prompted the introduction of REST, which is built on top of typically JSON, but you'll find other data formats as well. But REST is typically considered to be a lot more lightweight than SOAP. Obviously, it depends on the API. Now, RAML specifications and Swagger specifications are effectively the equivalent of WSDLs for SOAP. Okay, so these specification types kind of define how your API is going to behave at the resource and also at the endpoint level. Now, these two types of API formats, they tend to support contract-first development. And what I mean by that is, before you actually start the implementation of the API, you can build a concrete representation of how the end product would look like. And this is especially useful because it facilitates early buy-in from stakeholders using realistic mock-ups of how the API would look like once it is actually live and running. But it also facilitates developers because given that a contract has been defined prior to the actual implementation, you get tooling that can provide automatic code generation based on this contract. And here we can see some plugins and some tools for developers by which this can be achieved. Now, the benefit of APIs is also the fact that they are programming language agnostic, especially these standards. SOAP and typically JSON, they can be pretty much written in any programming language. So if you have a team of developers who are strong in one language and then another team, say for example, the first team is strong in .NET, but the second team is strong in Java, it doesn't really matter which team actually develops it, because the contract at the end of the day, it doesn't really affect whoever is consuming the API. Now, when it comes to actually managing APIs at runtime, you have these products which are called API managers. Okay. Now, API managers tend to help you manage the API implementation and also your contract in production. When it comes to features of API managers, you tend to get certain elements which aren't really tied down to the implementation of your system. In fact, some of these points here, these apply to any sort of any API that you will find out there. Okay, such as per client request filtering and reporting. So typically, every request that comes through your API is recorded and tagged against a specific client. So over time, you can see how what your adoption rate of your API looks like, who are your most active parties, so on and so forth. It can give you some metrics when it comes to successful requests and also error rates, so you can plug these into your monitoring tools as well for your operations team. And you can apply API level protection mechanisms so that you have some guarantees that your API won't go down because a client has gone or rather is spamming your APIs or calling it too often. And as I said earlier, you also have reporting capabilities based on error rates, successful requests, so on and so forth. API managers also typically allow you to protect your APIs. In fact, most of them, they allow integration with OpenID servers where you can delegate your authorization and also your authentication side of things to third-party services. There are many vendors out there who support this. However, typically API managers also come with a reduced set of this functionality out of the box. Namely, the one that is most common is client ID and client secret authentication. Now, API managers often define their own APIs, and this is especially useful when you want to plug in your API configuration in tools such as Jenkins or Travis CI. You can effectively define how your API manager should protect your API in some sort of file, and then in your deployment pipeline or whichever pipeline you have in Jenkins, you can use that or rather you can use the API of the API manager itself to configure it without having any sort of manual intervention. So, I guess in summary, we can list down these benefits when it comes to APIs. So, from what we've seen, APIs typically are used to abstract users and developers from the complexities of the underlying system. Okay, this is primarily why we build these interfaces, so that developers can have an easier time integrating with these core systems of your business effectively. They can also be used to stitch together several business processes. For example, you can have, such as what Ingram was mentioning, if you have a merger between two companies, you can build an API that would synchronize data between two systems via a single endpoint. They also force you to think long term, and in that way, you kind of, first of all, make sure that your API is easy to use, of course. but something that we see oftentimes is that you tend to build APIs which are too focused towards one specific system, and then as new features tend to be introduced, you tend to break compatibility, which means that now you have to support multiple versions of the same API. And this is basically what we call dead on arrival, because now you have the same problem as you started off with. Okay, so now you have point-to-point integration at the API level. So now this is why it's kind of important to think long-term. And if you do that effectively, they act as solid business foundations that can serve as building blocks for other projects in the future, because developers don't have to essentially reinvent the wheel. They can build on top of the successes of other teams who have actually built these APIs. Now, before I go into these slides, I'm just going to dive into what the endpoint platform actually supports. The endpoint platform is essentially a new soft solution to APIs, essentially, and also integration in general. So, sorry, hang on, let me just refresh this page. So what you see here is all of the areas of the endpoint platform. Okay, and the parts that I'm going to focus on are primarily the API manager, the runtime manager, and also the developer tools that you will find on this section. So let's start off with the design center. So typically, when you want to build an API, the first thing you do is you actually define the contract, and you go through several rounds of iteration with the relevant stakeholders. So what I've done so far as a sample, so to speak, I've defined a relatively simple API. It's something that can be used to search for flights against multiple operators and also different airports. So just wait until it loads. Okay. So here, what you see in front of you is an example of a RAML specification that defines effectively just a single resource, flights. This a little bit. So it defines a single flights resource with a single get operation. This is kind of intuitive. Okay, this is used to get a list of flights given a number of parameters. Now, the parameters here is code, which is effectively the airport code of where you want to fly to, as well as the airline with whom you want to fly with. So this tool can effectively be used to build your contract and agree with the relevant stakeholders of what this API is meant to expose and how it's also going to expose it. Security mechanisms, data types, and so on. Now, if you want to actually demonstrate the functionality of your API, this endpoint platform also supports a mocking service where you actually get a mocked version of your API implementation that will give you back like responses depending on what you've defined in the specification. So, for example, here on the right-hand side, you get effectively auto-generated documentation in the console with which you can use to test your API. For example, here you have the name of the API as well as the API endpoints. Okay, so the API endpoints is what the API offers in terms of operations. Okay, so at this point we only have a single operation to get the flight that accepts the destination airport code as well as the airline, and there are a number of different possible values for each option. So once I click on this mocking service option here, I'll be able to actually try out a mocked implementation of this API. So here you can see all of the options that I can select for this airport. The airport and as well as the airline. Okay, so if I had to choose Los Angeles Airport, for example, as the airport field and United Airlines, I expect something of the sort. Okay, so here you can see a mocked response that contains all of the flights for for United Airlines. Okay, for the developers amongst us, you'll notice here that you will also find flights for Delta. This is a mocked response, so there's no actual logic here. Okay, this is effectively serving me a file that is stored within this API definition. Now, after going through these iteration rounds and having an agreement of what this API is meant to do, I can publish this API definition to Exchange, and Exchange is a MuleSoft solution of where you can expose your API definitions both internally and also externally. Okay, so here I've published this flight search API, whereby both employees within my organization and also public consumers from other third parties, they can actually find this API definition and start integrating with it. So clicking on this, you will be taken to the description of the API. Okay, and this is actually public. So if I had to give you this URL, you will be able to actually see it and gain access to it. But this is something that the owner of the API can change. Okay, so this is something that I set up prior to the stock. In fact, here you can see some headings which details how this API, how you can gain access to this API. So once this API has been published to Exchange, it is done so against a version. Okay, so at this point, an implementation can be built towards this specification. Now, we build these implementations, or rather, we build the implementation for this API using a MuleSoft tool called Anypoint Studio, and this is effectively an Eclipse-based IDE where we get a canvas, and we simply drag and drop components onto this canvas that will define our integration or our API implementation. For example, what you see here is, let's see if I can expand this a little bit. So what you see here is like the interface onto my API, and this screen here kind of details the actual functioning of my API. And this is where you will be able to see some of the components that Ingram was mentioning earlier, specifically around filtering, routing, transformations, and so on. So once the developers are done with this implementation, they can go ahead and test it directly within Anypoint Studio. So you get an inbuilt Mule server by which you can test and reiterate on your implementation. And once that's done, you can also deploy it either to an on-premise Mule server or also to a cloud instance. In fact, if I had to navigate to the runtime manager, here you will be able to see an implementation of this API that is exposed publicly with actual logic behind it. Okay, so this API is effectively running on a publicly accessible box, effectively on Cloud Hub. This is MuleSoft's cloud-based solution for deploying integration applications. That is also registered to the API in Exchange. So whilst this is loading, let me just go back to Exchange to kind of explain how this is done. So from Exchange, here I've published this API definition. Now I need to manage it, okay? Because as I said earlier, the API manager kind of protects the front-facing side of your implementation, being the API tier, and then you have your application, your logic, sitting on a Cloud Hub box within Runtime Manager. So API Manager is used to protect this implementation effectively. So this Cloud Hub box, or rather this application, is registered with an instance of the flight search API. In fact, you can see here that it's active, and this is tied back to the Cloud Hub instance. So if I had to click on this version here, it will take me to the management screen of this API. So here you will get some metrics when it comes to the requests. Say, for example, here you can see that some requests have come in the last 3 hours. You will get some metrics when it comes to who the top applications are who are querying your API, as well as average latency for your API implementation. Now, when it comes to the security aspects, the API manager has something called a policy, and in fact here you can see several policies that are available out of the box. But what I've done so far, just to keep things simple, is I've chosen a rate limiting policy that will limit the amount of requests I am able to perform against my API. In fact, I've split my clients into 3 different tiers. In fact, here you can see that this policy is effectively SLA based, and also a client ID is required so that I can identify who the caller of my API is. Now, when it comes to the SLA tier, I've defined 3 different tiers. So the first tier is a free tier that allows you to supply, for example, 3 requests, or rather 1 request every 3 seconds. And then as you go up into the different tiers, you require manual approval from the owner of the API, in this case being my temporary demo organization. And this is something that you can use to kind of protect different areas of your API, or start charging different rates depending on the level of access towards your API. Now, getting access to this API can also be done via Exchange. So, navigating to Exchange, you will get this, just click here. So you will get this request access button, which you can then use to create your own application, being the client of the API. For example, let's call it just this application. And from here, you will be able to get, let's just select the API instance, as well as the SLA tier. So in this case, I'm just going to click free because it doesn't require any manual approval. So if I request API access, this is now going to give me a client ID and a client secret, and these 2 uniquely identify this instance, or rather this client who can actually query flights against that API. Now, given that this API is actually public, I can use a testing tool in order to perform some pulls against this implementation. So, just for the purposes of this demo, I've created a Postman script. Let's see if I can make this a little bit larger. This here is the URL where my API is actually hosted, and I've defined 2 headers, being the client ID and the client secret, with which the application that I've just created is identified. So switching back to Exchange here, I can grab this client ID, paste it here, client secret as well. And what remains is to actually define the operator as well as the airport to which I'm flying. For the time being, I've just defined the airport as being San Francisco, and I want to retrieve flights from all airlines, being United, American, and also Delta Airlines. So if I send this request, eventually it will hit the API, and I'll get flights that pertain to my filtering logic here, being San Francisco and all airlines. Right? Now, when it comes to the security aspects of the API manager, the response headers that come from this API implementation contain some headers that detail how many requests I am able to perform within the sliding window. Okay, the free tier contains 3 seconds, so I'm not able to perform more than 1 request every 3 seconds effectively. If I try to do that, then the API manager will actually reject that request. Now, the point I want to bring across here in all of this is that the API implementation itself does not necessarily need to be concerned about these security aspects. These are patterns that are effectively standard. These are the same regardless of the implementation for the most part. And most of these security features and enhancements can be applied regardless of where the API is hosted or pretty much where it's hosted and so on. That's it really. So let me just demonstrate this really quickly. Let me try to supply multiple requests within a short time window. And here, eventually, it is a little bit slow. Okay, so here you can see that the API manager has effectively returned an erroneous response where it's saying that I'm supplying too many requests within the allotted time frame. I think that's pretty much it. Just jump back here. Right, this sort of pretty much covered all of this. Before I hand the floor over to Luke, are there any questions?
What of this is enterprise?
Sorry?
What out of this is enterprise?
So API Manager in general is an enterprise feature, yes. However, when it comes to Anypoint Studio, that is something that is free, and then it depends what kind of new server, exactly which runtime you're going to run when you deploy your application either on premise or in the cloud. Sorry. Yes. So when you register to the Anypoint platform, the design center is something that you can use to define your RAM specifications. Having said that, you can also do that in Anypoint Studio. It has pretty much the same tooling in it.
And what about support for Swagger?
In the design center, I'm not sure whether that is actually implemented yet. Swagger is essentially an alternative to RAM.
Yes.
Now, there's something called the Open API specification, which I think is effectively a version of Swagger 2. I'm not exactly sure where MuleSoft actually have arrived to when it comes to Swagger or the Open API specification. I've seen it float around in the Anypoint platform interfaces, but when it comes to actually defining APIs in Swagger, I'm not entirely sure.
It's a bit messy.
On the design center.
On the new community.
All right, fair enough. Personally, I've only ever used them so far, so Swagger I haven't had an opportunity to work with. Yes. All right, thank you very much.